Hi, welcome to my channel, JaberTime. Today I'm going to go over probabilities using tree diagrams and area model, and I'm going to go over 7 examples. Let's get started. The first question is about double spin, titled, Double spin is a new game at the fair. The player gets to spin the spinner shown twice, but wins only if the same amount comes up on both times. The $100 sector is 1/8 of the circle. Doing the math, this is 1/4 or 2/8. 1/4 or 2/8. This is 1/8, and that should be 3/8 to make it all 8 out of 8 or 1. Think about 1/8, 1/8 and 3/8. If you add them up, that's 4/8, which is half. So the left side is half and the right side is half. What is the probability of winning $100? What is the probability of winning anything at all? Now I'm going to start with the tree diagram. I am saving a lot of time for you, so I have it all done. And notice that I'm kind of like coloring or underlining some answers. Few things that you need to know. For tree diagrams, these branches right here, for the first time you spin the spinner, should add up to 1. Every time you have it, second spinner, if this is the first outcome for the first time, should also add up to 1. This should also add up to 1. This should also add up to 1, and this too. Sum equals 8 out of 8, which is 1. Not only that, if you add all these, that should be 100%, 64 out of 64 in this case, which is 1. Okay, let's move on. What is the probability of winning $100? Well, as the problem says, you win $100 if it shows up on the first spinner, or the spinner points to $100, and on the second time also points to $100. So we are going 1/8 times 1/8, which is 1/64. That's the first part. Second part, what is the probability of winning anything at all? Well, you could win $10 if it lands on $10 in both times. So I have 1/4 or 2/8 if you want to keep it all consistent with the same denominators. Same thing for the second time, and you end up with 2/8 times 2/8, which is 4 out of 64. It's underlined. How about $5? Well, $5 will give you 2/8. As you can see, it's still 1/4 or 2/8. Same thing right here, which is 4 out of 64. And $1 will give you 3/8. 3/8, that's 9 out of 64. Well, of course, less money, you'll have more chances to win. Add these up, you'll get 64 out of 64. For this problem, we're going to add the underlined ones to answer part B. 1 out of 64, 4 out of 64, 4 out of 64, and 9 out of 64, which is 18 out of 64. Okay, one more time. So it says make a tree diagram or an area model. We did the tree diagram. Let's do the area model. First spinner or first time, second time, it's identical. It looks like a square. Some books, they make this lengthier than this, but it doesn't matter as long as you know and you are careful by writing the answers inside. So for the first time, you might get $100 or point to $100 as a result, or $10 or $5 or $1. Second spinner, or second time you spin the spinner, you get $100 or 10 or 5 or 1. Well, to get $100, that's 1/8. To get $10, which is 1/4, as you can see, we talked about that, which is 2/8. You get $5, same idea, 1/4 or 2/8. $1, 3/8 when we did the math. Same numbers applies here. Multiply 1/8 times 1/8, if it lands on both $100 in each case, that's 1 out of 64. In case it lands on $10, that's 2 out of 64, sorry, 2 out of 8 times 2 out of 8, which is 4 out of 64. I'm highlighting or circling the middle ones because that's when it lands on the same amount twice. Okay, that's the area model. Area model, it's useful, as you could see, but sometimes it's a little bit hard. For example, if you spin the spinner 3 times, that's going to be 3-dimension, and we're talking about area model, not volume model. So area model works when you have a spinner, you spin it twice, or a coin that you flip it twice, 2 coins, not 3 coins, and so on. It does have benefits, as you could see, but it has its own limitations. Winning $100 is 1 out of 64. Winning anything, that means $100, $10, $5, $1, and add them up. Same answer, of course. Let's go to second problem. You are playing a game with a friend, and that is flipping 2 coins, a penny and a dime. Well, it doesn't matter if you have 1 coin, you could flip it twice, and so the names doesn't make any difference. Penny, dime, quarter, nickel, doesn't make any difference. Of course, also, it doesn't make any difference which one do you flip first, because if you have 1 coin and you want to flip it twice to get an outcome of 2 things like head, head, and so on, something to keep in mind. It doesn't make any difference what do you have, if they are identical or not, or if it's a penny, dime, quarter, and so on. Make a 3D diagram or an area model to answer the following questions. I have them. Let's go one by one. I don't want to read them all, then start answering. So let's do the 3D diagram. Here's the first coin, and here is the second coin, or the first time you flip, second time you flip, or the penny and the dime. On the penny, you might get a head, which is 1/2, of course, if it's a fair coin. Tail, you get 1/2. Second coin, you get head 1/2, tail 1/2. Or if the first outcome was tail, you still have the same options for the second coin. So it's all halves everywhere. Multiply half times half, that's how you get the result right here, which is 2 heads. Head on the first, tail on the second, head on the first, tail on the second, still 1/4, because 1/2 times 1/2 is 1/4, and the story continues. Now, let's try to answer the questions one by one. How many outcomes are there? Those are the outcomes at the end of the branches. 1, 2, 3, 4. So the answer is 4. List the elements in the sample space. Well, I have them here somehow, but you could read them here. Head, 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 tail, tail, head, tail, tail. That's a sample space as a set. So we have 4 elements inside, and those are the outcomes. What is the property of getting 2 heads? 2 heads would be this one, and they are all equally likely, and it's right there, which is 1/4. What is the property of getting 2 tails? That's this one here. It's identical to 2 heads. That's going to be also 1/4. What is the property of getting 1 head and 1 tail? Well, 1 head, 1 tail, I have 2 options, as you could see. Either head on the first, tail on the second, or tail on the first, head on the second. And you could see them right here. This one and this one. So we add them up. 1/4 plus 1/4, 2/4, which is 1/2, 50%. What is the property of getting no heads? Well, no heads means all tails, and that's going to be 1/4. What is the property of getting at least 1 head? Well, heads could be 0 as number of heads, or 1 or 2. When it says at least 1, that means 1 or 2, excluding 0. 1 head, 2 heads. That's going to be 3/4. Okay, I think we're done with this problem. Let's go to problem number 3. I have 7 problems total. Number 3. You have a different type of spinner right here. It says the following. You are playing with a friend by spinning the spinner twice. This spinner right here. The game is that you will win the amount of money, which is you win nothing right here, $0 or $4, if it lands twice. The amount of money that you land on twice. That is, if the spinner lands on 4, on each time you win the $4. To get started, here's a tree diagram. First time you spin the spinner, you might land on 4, you might land on 0. 50%, half, half, as you could see. 50% chance for each. Second time you spin it, either $4 or $0, it will land on 50%, same idea if you're coming from 0 on the first spinner. Doing the math, it pretty much is similar to the coins halves all the way, the last problem. And I could see here a comment that says the probability of winning $4, which means landing on $4 on both times, that's going to be half times half equals 1/4. Make sure you multiply, not add, when you use the branches. I did not mention that earlier, but that's what you do. In a different video, I'll explain more about the second part, which is called conditional probabilities and so on. But let's just keep it consistent right here and focus on these problems. So one more time, when you go this way, you multiply, and when you go this way, you add them to find out the total as 1. Well, of course, if you add them, that's 1. 1 means 100%, which does not make sense. So what is the probability that you will win $4, which I just answered? That's 1/4, which is 25% if you want it as percent. What is the probability that you will win nothing? Well, you will nothing if you land on 0, differently speaking, which is 1/4 plus 1/4 plus 1/4, which is 3/4. 75%. How is that? Now, if you land on 4 the first time and you land on 0 the second time, you lose. You don't win the $4. If you land on 0, of course, so far you're not gonna make any money. So that is not a winning, that is not a winning, and that's not a winning. The only winning one is if you land on 4 both times, that's 1/4. The rest are losing or not making any money. So that's the reason why it's 75. All these 3 will be the part B answer. Let's go to number 4. What if the spinner looks like the one below instead, or on the side? You are spinning the spinner twice at this time, and you will win the amount that the spinner lands on in both times. Otherwise, you win nothing. Make a tree diagram or an area model to answer the following questions. We'll go through this once we see the tree diagram. Here we go. First time you have 3 options, as you can see. Second time you have 3 options. Either you're coming from here or from landing on 4, 3 options for the second time, or from landing on 0, 3 options for the second time. Either you land on 100 or 4 or 0. Either you land on 100 or 4 or 0. 100, 4, 0, 100, 4, 0. The way I graph this, I usually start on the right side. I kind of like make it equal distances, and I go backwards. Then I end up at this point. So to graph this by hand, it's a little bit hard to start from this point. Give it a try if you want, and you'll see what I mean. It's kind of like when you start right here, you want to squeeze these ones, but knowing the distances at the end, I could just go back in the middle right here and connect them. So before we jump into the answers for part A, B, C, let's take a look. 100, 1/4, yes. 1/4 for the second time. That's 1 out of 16 to land on 100 on both cases, because you multiply 1/4 times 1/4. And if you add all these fractions, you should get 16 out of 16, which is 1. Okay, what is the probability of winning $100? I think I just answered it right here. So 1 out of 16. For the $4, we're gonna 4, and we have to go $4, so it's kind of like straight this way. That's still 116. What is the probability of winning nothing? Well, to win nothing, you're gonna look at the other ones besides part A and part B, which means here you're not making any money, of course. Landing on 0, then landing on 4, you're not making any money. This is a lengthy way to look for them because there is only 2 ways that you could win, either $4 or $100. Other than that, you're not gonna win. If you land on $100 first time, second time you land on $4, that's not winning according to the game. So the best way to do it is called complements. So I know the whole thing is 1 or 16 out of 16. 2 will be excluded because we are winning nothing here. Take out the $100 chance and the $4 chance, and that should be with common denominator 16 out of 16 minus 2 out of 16, which is 14 out of 16. That should do it for this problem. Let's go to number 5. You are playing the following game with a friend. Each player will spin the spinner shown twice and will win the amount of money shown in the result if it lands on the same amount in both times. 3-diagram. This time it's not different fractions or different portions. For $3 it's 1/4. For $1 it's 3/4. As you could see, chances. Same idea for the second one because the spinner is spinning. We're gonna spin the spinner twice, and so it's identical for the second time. 1/4, 3/4, 1/4, 3/4, 3, 1, 3, 1. Multiply 1/4 times 1/4, 116. 1/4 times 3/4 is 3 out of 16. If you add these numbers, you could tell that's going to be 16 out of 16. Let's double check quick. 9 and 1 is 10. 3 and 3, 6. Yes, 16 out of 16. The highest chance would be for $1, which makes sense. 3 out of 4, 75%, 75%. Multiply them, that's 9 out of 16. Okay, what is the probability of winning $1? That's $1 on the first, $1 on the second one, and that should be 9 out of 16. Part B, what is the probability of winning $3? Well, $3, that should be up here, and that is 1 out of 16. Winning nothing, that means you're not winning the $3 and you're not winning the $1, which means you're gonna go $3, $1, that's 3 out of 16 right here, or you land on $1 first and $3 second, $1, $3, that's 3 out of 16, and the math is written right here, a total of 6 out of 16. How about winning anything? Well, winning anything, that means the $3 and also the $1 on your side, you're gonna add them up. 3, 3, 1, 1, that's winning 116, 1, 1, winning $1, 9 out of 16, add them up, 10 out of 16. Now number 6. You are playing the following game with a friend. Each player will spin the spinner shown 3 times. This time it's 3 times. And will win the amount of money shown in the result if it lands on the same amount in all 3 times. Here's a 3-diagram, kind of lengthy, because you're gonna do it for the first time, for the second time, and for the third time. What is the probability of winning $1? Well, winning $1, you're gonna go through this way. That's 3/4 times 3/4 times 3/4, which is 27 out of 64. That's the only way that you could win $1. So just going through the same amount in all 3 times. What is the probability of winning $3? To win $3, you have to go $3, $3, $3. That's 1/4 times 1/4 times 1/4, which is 1/64. What is the probability of winning nothing? Well, either you win $3 or you win $1. But if on the first time it lands on a 3, second time it lands on a 3, and the third time lands on $1, you're not gonna win, because it has to be all 3 times. So 3, 3, 1, that's not winning. Same thing for the other ones. Instead of adding all these fractions and taking off or ignoring this and this that were mentioned in part A and part B, we could do what's called the complement, and that's winning nothing 1 minus winning $1 and winning $3. So add these fractions, use a common denominator, and you end up with 36 out of 64. That should do it for this problem. Let's go to the last problem, number 7. Number 7, you have 2 bags, as you could see. I usually, after a lengthy paragraph like this, try to take the math out as a figure. That helps a lot, and we'll stick to the numbers right here when we see many parts like A and B and C and so on. Elisa and Lisbeth had just lost playing double spin, so they had enough also with double spin. They moved on to a different game. When they ran into another game, they had never heard of what's called pick a tile, in which the player reaches into 2 bags, as you could see right here, and chooses 1 square tile. Those are square tiles, and those are circular tiles. 1 square tile and 1 circular tile. The bag with square tiles contains 3 yellow, 1 blue, and 3 red squares, as it shows right here. The other one, the bag with circles, has 1 yellow and 2 blue circles, a total of 3, and here a total of 7. 3 and 1 and 3. To win the game and a large stuffed animal, a player must choose 1 red square and 1 yellow circle. Make a tree diagram or an area model to answer the following. Here's a tree diagram, so while we are reading part A, look at the tree diagram and answer the question and save you some time. Find the probability of a player choosing the winning red square, that is red square, yellow circle, yellow circle. So you're coming this way, 3/7, because yellow are 3 out of 7, and 1/3 yellow circle, 1 out of 3 for the yellow circles, 3 out of 21. And that's the answer. Part B says find the probability of a player choosing the blue square, that's the blue square, and blue circle, blue, blue. 1/7 times 2/3 blue circles are 2 out of 3, and the answer would be 2 out of 21, which is right here. How about if we go for area model this time? Here's an area model. This is the first bag, 3 options. Here's the second bag, 2 options, with the chances of getting the yellow square, the blue square, and so on. Multiplying 1/3 times 3/7, I get 3 out of 21, and so on. Looking at the first part, red square, yellow circle, red square, yellow circle, multiply 1/3 times 3/7, that's 3 out of 21. And blue square, blue circle, blue square, blue circle, 2/3 times 1/7 is 2 out of 27, and that should do it. Thank you for watching. I'll see you in the next one. Thank you. Thank you for watching. Don't forget to hit the like button, subscribe to see some more, and I'll see you in the next one.